Hi everyone! Today I'm in the kitchen because we're going to be learning about water's ability to dissolve materials and things might get wet. First, let's start off with some instructions on taking notes. Get out a sheet of notebook paper and write "Water as the Universal Solvent" as the title. Second, your notes today are going to be visual, meaning you should draw pictures anywhere you can and make definitions bold and colorful. Lastly, whenever I say a vocabulary term, pause the video and jot it down in your own words in your notes. Okay, now that we've covered how to take notes, let's get started with the lesson. Water is called the universal solvent because it dissolves more materials than any other liquid. I have some cold water here, regular plain old cold water, and a Kool-Aid packet to demonstrate this concept for you. I'm going to tear open the Kool-Aid packet and just pour it into the water, and we'll come back to it later. So in order to fully understand this concept, let me first describe what a solvent is. A solvent is a liquid that is able to dissolve other substances. And let me repeat that so you can pause the video and jot it down in your notes. A solvent is a liquid that is able to dissolve other substances. Next, substance that is dissolved is called a solute. Let me repeat that. A solute is the substance that is dissolved. Finally, the end product is the solution. Solution is a new substance that is formed when the solute is completely dissolved in the solvent. One more time. A solution is the new substance that is formed when the solute is completely dissolved in the solvent. So think of it this way. Solute plus a solvent equals the solution. So let me write it for you. So solute plus solvent equals solution. Pause the video and make sure you have this in your notes. Okay, next you might be wondering why water is a universal solvent. Water molecules are made up of hydrogen and oxygen. The hydrogen in a water molecule has a positive electrical charge and the oxygen has a negative electrical charge. Together, these two elements can become heavily attracted to many other types of molecules, and because of this, they upset the attraction of the other molecules and tear them apart. For example, when you put salt in water, the water molecules disrupt the attractive forces between the sodium and the chloride in the salt molecule, and it dissolves. Think of it this way. Tears apart and dissolves. So let's check back in on this Kool-Aid. Looks like you can see some of the yellow at the bottom. It hasn't dissolved, and then more of it as you go up to the top has dissolved already. So I want you guys to pause the video for a second and make predictions about what's going to happen when I stir in the rest of the Kool-Aid. Alright? Great. Now obviously all of you have had Kool-Aid before, so you know that it's going to dissolve into water, because you don't drink Kool-Aid when it's still in the powder packet form. So pause the video again and think of something else and draw it in your notes that dissolves in the same way. Alright. Although making Kool-Aid hardly seems like an experiment, my demonstrating this to you is just one way You can draw conclusions as to what kinds of substances will dissolve in water. Tomorrow in class, we're going to investigate some more into various solutes and if changes in the solvent can cause the solute to dissolve differently. That's all for now, folks. Come to class tomorrow ready to make some solutions.